Welcome everybody to the January 26th, 2020 free GMAT prep hour for Manhattan Prep. I will be your host, Reed Arnold. This is, I think, the first free GMAT prep hour this year, if not the first, the second. So welcome back. Hope this is your New Year's resolution to excel at this test and get into the business school of your choice or other program if they accept the MBA. So these free GMAT prep hours we do once or twice a month. The instructors at Manhattan Prep get to choose a topic that they kind of want to discuss regarding their test, either a specific study habit, a specific topic. I've taken the test live, so we do these every few weeks. Come back, check it out. It's free. See what advice we have for you to improve your GMAT score. If you are looking for other free options, you can try any one of our classes online or in person for free. The first session of 9, that's 11% of the entire course that you get, no questions asked. Try out a professor, teacher. I sound like one of my own students who call us. Sometimes I get called professor, and I always kind of chuckle at it because we're not professors, we're GMAT instructors. Try out a GMAT instructor and see if you like their vibe, see if you want to take the course, see if you like what we offer. You can also try our Interact course. That's our online self-paced study. Really great video training system. Try that out for free, get a sample of that. And so visit that link, learn more. All right. Today, friends, so I was wondering what I wanted to talk about. One of the fun things about the free GMAT prep hours is that we teachers sometimes get to talk about things we don't talk about much in class. There's always some variability in class. We go on certain tangents, we go into certain things, but we try to cover certain topics every time. And there are some that just are some strategies or some topics that you just never quite have time for. And this is a new topic for me. This is one I've only just started doing and starting to realize the value of. And so I've started to creep it into class, but I wanted to make a video for it so that you could see it in action, and so that I could send it to students who maybe would benefit from studying or practicing certain questions this way. I started doing it, frankly, because it was one of my own glaring weaknesses on the test. Certain topics, namely absolute value and inequalities, especially when the two intersect, I really struggled with them. I could sometimes like brute force my way through the question, especially if it was a Datasufficiency and I could test cases and just make sure that the rules were followed and get different answers and just do the old testing cases thing. But as like a concept, I just could not grasp it. And so I searched other ways to do it, and this was kind of the way I've stumbled on. And I certainly didn't invent it, but I've found it very beneficial for certain questions in this category. And it's basically using a number line to visualize the numbers that you're dealing with in the question and the variables that you were dealing with in the question. So I've drawn a little sample number line here where we have 0 and 1, and then x and y. My thought is like, x is somewhere, it's a fraction, somewhere in this range, and y is somewhere bigger than 1, and maybe you have z somewhere negative, I don't know, something like that. And the fact is that where numbers are on the number line, it kind of changes how they behave, and that's worth knowing for certain questions. And many questions will deal with where the number ends up on the number line relative to typically 0, 1, or -1. Is another important number. These are kind of the 3 numbers to look out for. Where are those things? Particularly, as we'll see today, where is 0? So you'll wonder where the variables fall relative to those, or where the variables fall relative to each other. And sometimes, yeah, you can throw out numbers and just grind through, but sometimes it helps to actually see the thing and put it on paper and pen. So that's what we're kind of working with today, is visualizing numbers with a number line. Okay. There are other ways to do the questions we do today. This is not the only way. I just want you to practice it because I do think it is helpful. Sometimes it is the easiest way. One just quick arithmetic trick that I've learned utilizing this method is how we can turn subtraction into addition. It's actually just kind of like a psychological truth that people are better at addition than they are at subtraction. Who knows why? My own armchair psychologist theory is that we're people, and losing things has almost always historically been terrible. And so we just didn't learn to get good at it because we learned to avoid it. Because it's hard to imagine in the state of nature losing something and being glad about it. You're always losing food, or losing members of your tribe, or losing land to another, soldiers, whatever it is. Like, losing was always bad. And so I just think psychologically we got averse to it. And that means that addition tends to be a little just smoother than subtraction. And I've learned that you can use a number line to turn subtraction into addition. So here's just a quick example. Okay, quick, what's 100 minus 22? 5 seconds. 5, 4, 3, 2, 1. Okay, what do we get? Okay, did anyone get 88? I don't know about you, but I get 88 all the time with this question and questions like it. 200 minus 22, 188, 300 minus 22, 288. I just go to 88 immediately when I see 100 minus 22. And that's not correct. It is 78, as some of you are noting. But you can actually use a number line to visualize a subtraction. If you put 122 on a number line, what you are doing when you subtract is finding the distance between them. The way we're usually taught subtraction is like, I have 100 apples, I lose 22 apples, how many do I have? Sure, that works too, but you can also think about subtraction as a distance between values. And so if I start at 22 and I want to get to 100, I can actually, instead of subtracting, I can be like, okay, let's find a nice common benchmark first. Let's go to 30, and that's 8, and then 30 to 100 is clearly 70. So I add those distances together and I get 78. Now, do you have to do a subtraction this way? Of course not. But I do think it's kind of handy. I do think it's kind of neat. I do think it's going to save you mistakes sometimes. So just for practice here, take 2 minutes to do these questions using number line subtraction. All right, friends, start wrapping this up. So if I were to do 121 minus 56 here, I'd put 56 over here and 121 over here. And let's find some nice numbers. So the first off is probably 100 will be great. That'll be 21. 56, let's go to 60. That'll be 4 and 40. And so I have 4 plus 40 plus 21. It's 4 plus 25, that'll be 65. Okay, that's just, again, do you have to do it this way? Of course not. But first off, this feels, just so you all know, it feels GMAT-y to do questions this way. It feels like something the GMAT tests, and I think understanding numbers this way will help us in the much harder and much more abstract questions we're going to deal with here shortly. 76 minus 58, again, 58 to 76. I would probably do 2 to get to 60. And then 60 to 76 is easy, that's 16, so I'd get 18. Okay, great. 730 to 412. This one's a little bit tougher. This one you might actually find easier to do it this way. Go ahead, if you in the chat, I'm just curious if anyone did find it easier or surprisingly pleasant to do the subtraction in this manner. I'm just curious what your thoughts were. So that's a distance of 8. So someone said surprisingly faster than usual, and it's like, yeah, it kind of is. Let's go 420 to 500 is going to be 80. And then it's 230 to get to 730. So 8 plus 80 plus 230, that would be 80 plus 230 is 310, plus 8 is 318. Okay, Lily, I apologize. If you didn't know what to do, that is my fault for not explaining fully what I wanted you to do in the subtraction exercise. Okay. Jay says using less processing energy. I like that too. It might take a little longer, but if it's easier, it might be worth it if you just don't have to think as much. And also, if you're not going to make as many silly mistakes, that's great. Also, if I make a mistake, let me know, because I might. 143 minus 192. This one's kind of fun because you might notice that this one needs to be negative, right? The smaller number is first. I'm actually subtracting 192 from 143. Well, there's a way to handle that still. I just add it up and make it negative. That's it. So 143 to 150 is 7. There's 150. That's 7. Then I have 150 to 192 is 42. That's easy. I can do that in my head. So I have 49, but it's negative, so I have negative 49. That's one where I'm like, that had to be faster, or at least easier to do it that way. Maybe not. But I learned this trick, and I love it. I think it's great. So just the first level of like, hey, sometimes it's nice to use number lines to do math rather than actually do the old, school pen and paper calculations. So let's think about dealing with this in a more abstract level. So I have here, I didn't even count, several examples of questions that use variables. And I want you to think about the number line, or maybe different number lines. Some of these might have multiple possible number lines based on the relationships of the variables given. But I want you to actually visualize and put these on the number line. This will take a little bit longer. So I'm going to go ahead and, probably 5 minutes for this one. Okay. Try to come up with the different possible number lines based on these relationships. All right, I'm going to stop there a little bit soon, just to keep going. Make sure we get in a full class. These things always go faster than I intend for them to. So if x minus y is greater than 0, I can rearrange that to say x is greater than y. And yeah, we've seen that before. We know what that is. I don't know why, but for some reason, all of a sudden, it just feels more grounded as soon as I see what that really is. What that really is that x is to the right of y on a number line. That's what it means. That's all it means. Now, we don't know where this is. We don't know if 0 is over here or over here or all the way over here. It's a really long line. Who knows? Okay. But if x is greater than y, we know that x is to the right of y on a number line. If y minus x is greater than 0, it's the opposite. We know that y is to the right of x on a number line. Okay, that's just what those mean in number line geometry. X plus y is greater than 0 is a little bit different. And we have to think about some possible number lines here. The most basic number line is like, hey, here's 0, and x and y are both positive. And it's not really clear which one's which. You know, y could be bigger than x could be bigger than y. They could be equal. I don't really know. But there is another possible number line where one of them is negative. But what must be true if one of them is negative? The other has to be more positive. So I can like visualize that. I can put x, you know, here's x positive, here's y negative, but x is further away from 0. I actually can visualize that, or I could reverse it and say, you know, x and y, if y is the positive one. I can't have them both be negative, though. If they're both negative, that's not true. Just not going to work. Okay, so these are kind of the two possibilities, and in a way it's 4 possibilities because we don't know which one's bigger, y or x, for the number line when x plus y is positive. If x times y is positive, again, doesn't tell us much, but it does tell us either x and y are both positive or both negative. Okay, we're either in this world or in this world for D. E is the opposite. If x and y are, x times y is negative, I either have x, 0, and y, or I have x, 0, and y. They are on different sides of the number line. Jay says, for D, how do we know if x is to the left of y or vice versa for D? We don't. We don't know that. I guess I should have clarified. We could have had, you could have had y and x, or x and y, and same thing over here, x and y, or y and x. But the point is that they are clustered together. If I were moving really fast, or being really savvy, I'd use different colors here to symbolize that. That'd probably be smart. So I could have blue, x, and y and x. Or I could have something less than 0, x and y. That yellow doesn't show up very well, and y and x. Okay, and then 0 would be here. It's one of the two. It's either the blue or the yellow, not both. For, let's see which one we're on. For f, the absolute the absolute value of x. Absolute value is a measure of distance. And that's, I'll just be honest, that was really what kind of was a game changer for me in number lines, was realizing how to visualize absolute value as a distance between things. If it's just the absolute value of a number, then it is the distance between that number and x. I'm sorry, if it's the absolute value of that number and 0. So absolute value of x is the distance between 0 and x. So it could be either this, where this distance is obviously x, or it could be this. Okay, and this distance is actually the opposite of x, because x is negative in this case. Okay, but that absolute value, you can think of it as being the distance from 0 to x. It's this measurement here and this measurement here. Okay, and then x minus y, this is when things get really fun. Hold on to your hats. Is when we bring in two variables. The absolute value of x minus y tells us, and again, we don't know which one it is. We don't know if x is bigger than y or if y is bigger than x. But the absolute value of x minus y is the distance between the two. It's this length. This is the absolute value of x minus y. And I know we'll see where this gets useful. I know it's still kind of abstract, but we're going to see how this is actually useful to solve questions here shortly. Okay. If x minus y is greater than 0, I'm actually not going to repeat it because that's the same thing as x times y being greater than 0, same situation. If x over y is greater than 1, that's a little bit different. Okay, I know that if I have 1 and 0 and x over y is greater than 1, then I know that either, I guess it could be here too. I know that they're both positive and x is bigger than y. That's what that means, if they're both positive. Or they're both negative. They can both be negative. And x is less than y. Okay, so they're either both positive and y is less than x, or they're both negative and y is greater than x. This is for G. Yes, thank you, Jay. This is for G. Okay. I just know that relationship exists on the number line. If x over y is less than -1, it's a similar kind of setup here, except I know they have different signs. So I know that if x over y is less than 1, I know that either x is positive and y is less negative, or y is positive and x is less negative. No, undo that. That's not true. Shh. X would be positive and y would be less negative, or x could be negative and y could be less positive. That's what that would mean for x over y to be less than -1. Y is closer to 0, and we're not sure they're on opposite sides of 0. Okay, so this is for H. If x minus y equals 4, again, subtraction is often a measurement of distance. So if x minus y is 4, I know x is here and y is here, and there's 4 between them. And if x minus y is -4, then I know that x is here and y is here, and there's 4 between them. Okay, so this is here and this is here. Okay, now let's put this to use. That's an introduction. That's a good 25-minute introduction to like what the heck we're doing here. Now let's see how it's useful in questions. So we're going to start with a simple question, but it'll just help you visualize. Go ahead, take, I won't give you a full 2 minutes here because I do want to get to the harder, more fun stuff, but take a minute and a half or so and work on this data sufficiency question using number lines. Okay, friends, so the question is asking, is r to the right of -6 on the number line? That's the same thing as asking, is r greater than -6, if they wanted to use the symbols. So we have 0, we have -6 over here, and we're just kind of wondering, is r somewhere in this direction, not including the endpoint of -6. Statement 1 tells us r is between -4 and -1. Okay, so let's take -4 and -1, and it's pretty clear in the picture here that yes, r is between, or that r is to the right of -6. This range, -4 to -1, falls to the right of -6, so that would have to be sufficient. The answer would be A or D. Statement 2 tells us that r is between -3 and 1, and so it's okay, well, here's -3, here's 1, and it's a similar idea. we can see that all this range is to the right of -6, and so the answer must be D. Each statement alone tells me that R is somewhere. You know, when I combine the statements, I get a little bit of a more narrow range. When I combine the statements, I know that R is somewhere between -3 and -1. Okay. But the question just asks, is it to the right of -6? And both statements tell me it is. So the answer is D. I didn't mention this before, but if you do have any questions, always feel free to interrupt me in the chat and let me know. But otherwise, I'm gonna move on to the next question. Okay. Let's skip that one. That one's similar and it's helpful, but we're gonna go to, I think, some more fun situations. So Jay's asking a reminder of how to draw x minus y absolute value, how to do this one. And the way to visualize that is the answer was D, Richard. The absolute value of x minus y is the distance between x and y on the number line. So wherever x and y are, I don't know what they are in this setup here, but this right here is the absolute value of x minus y. It is the distance of, no idea, Jay, I don't know where 0 is. That's also why this is, you know, if you like, it really helps to just pinpoint exactly what the math means. I have no idea where 0 is. 0 could be anywhere. It could be here. It could be here. It could be all the way over here. I don't know. But I know that x minus y absolute value is the distance between x and y. It's this line. Okay. Okay. Yeah, let's see. We'll come back to that one. I think if we have time, that one's a little bit of a different game. I want to do this one here, because this one is much harder, but also I think will help really hopefully sell you on the value of this whole exercise. Take 2 minutes for this one. What answers are we getting for this question here? And I apologize if you didn't know this was Datasufficiency. I should have put those answers up. Okay, we're getting a B, C, A. 3 people, 3 answers. That's always fun. C, okay, cool. So this question here is actually a little tweak of an official question from an official practice test. So this is based on a real question. It's actually this question. And I'm sorry, the screen is kind of strangely formatted there, but that was just how the screen grab happened. I just took out whenever it said the distance between A and B is 18, I made that the absolute value of A minus B is 18. I turned the English into the math symbol of it, just to, I think it looks harder. It makes it more complicated, quite frankly. Same thing with C and D, and I want to know the distance between B and D. Okay, and then all of these things, the distance between C and A is the same as the distance between C and B. A is to the left of D on the number line. I turned this is a hard question, but I made it much harder by taking the English and putting it into math symbol form. If I can make the page stay. Okay, so let's use the number line. This question is like right up my alley of I hate that. I don't like absolute values, especially when they're mixed with inequalities. It bums me out, but doing this number line work has really kind of helped. So I'm first told that the absolute value of A minus B is 18. And so it's like, I don't know where they are. I have no idea, but I do know that they are 18 apart. So I have A and B and 18 apart, and maybe it's B and A, who knows? Okay, and then I'm told that C minus D is 8. And I don't know where C minus D is relative to A and B. It's kind of a totally different situation. I have to treat it separately for the moment, but I know that they are 8 apart. So I have C and D. Again, not sure. I'm sorry. Yeah, C and D, 8 apart, and I'm not sure which is bigger than the other. Those are the possible outcomes. Okay, and I want to know the distance between B and D. How far apart are B and D, which are in their own little worlds here? Now, this is a question where, like, I'm sure you could theoretically pick numbers. I do not want to do that. That seems like it'll be a total, utter headache. Okay. Instead, let's use this number line knowledge. So statement 1 tells me the absolute value of C minus A equals the absolute value of B minus C. So that tells me the distance between C and A is the same as the distance between B and C, which means that C, if I put it on the number line with A and B, the distance between A and B, I'm sorry, the distance between A and C here must equal the distance between B and C here, which means C must be the midpoint. That's what that means. Okay, so that tells me that I have 9 and 9 around C. Cool. Now the question though is, what's the distance between B and D? And the answer is, I don't know yet. I don't have enough information. I know that D is 8 away from C. So D is either here or here on this number line. Where is it relative to B? I don't know, because I don't know where B is either. B, it's either, you know, they're either right next to each other, or they're right next to each other over here, or they're on opposite sides. Use a different color. Or they're on opposite sides across B and D, or on opposite sides across here, B and D. I just don't know. I don't have enough information. But I know it's going to look something. These are my options right now. All in one picture. This is what I know from statement 1, but it's definitely not sufficient. So A and D is out. So I'm left with B, C, and E. Okay, statement 2 tells me A is greater than D. Well, up front, that's without statement 1. Remember, this is all statement 1's work. Without statement 1, I don't have much to go on right now, because I don't know if C and D, you know, here's my C and D being 8 apart. I'm told that A is greater than D. I don't know if A is here and D is here. I don't know if A is like all the way over here, who knows where, and B is 18 away from A. So I don't have enough information from that. So it's definitely not B. Now I bring the two together. Okay. Now I bring the two together where I'm told that A is greater than D and C is the midpoint, basically. Well, if A is greater than D, it takes out this possibility. Yeah, I'll type those up in a second, Olivia. I apologize. I should have put those up. I forget that This isn't my class, and students aren't introduced to all the answer choices of data sufficiency right off the bat. I'm presuming you came in with some study, which is not a fair assumption. But I know from statement 2 that I can't have A here and B here because D is greater than A in this first line. So that's out. So I know that I have B and A being 18 apart, and C is in the middle. But I don't know if D is here and 1 less than A, and 17 away from B, or if D is here and 17 less than A and 1 away from B. So because I still don't know which line I'm on, the question being, where is D? Is it here or is it here? Both are possible under both these situations, and so the answer must be E, no sufficiency. So the way to remember the answer choices on data sufficiency is 1, 2, 10, 12, 10. Okay, and that stands for statement 1 alone is sufficient, statement 2 alone is sufficient. Together, the statements are sufficient. Either statement is sufficient, either alone, or there's not enough. I can't answer the question. That's what that means. And the answer to this one is E. But it's not easy to get there. It's a hard E. And again, picking smart numbers is a way to do this question. But oh man, it really bums me out. Just going through the visual possibilities, I think, is much, much nicer. And just seeing those relationships. Okay. So let's do another tricky question where I think you will be aided by the use of the number line. Take 2 minutes for this official guide, or not official guide, but an official practice test question. Okay, it's about 2 minutes. Now this is a tricky question. For one, it's sneaky. It's pretty sneaky. I'm given this ax plus b equals 0, which means that a times x equals the opposite of b. Okay, and I'm asked if x is greater than 0, and it's sneakily purely about positive negative. It seems like you might be like, well, how big is b? How far away from 0 is b? How far away from 0 is a? But ultimately, this question is just going to hinge on positives and negatives. Okay, so let's first think about this constraint if a times x plus b equals 0. When that happens, well, if x is positive, okay, if x is a positive number, and a is a positive number, again, not knowing anything about the quantities, I do know one thing. I know that b must be negative. That has to be true. If x is a positive number and a is a negative number, I know that b must be positive, because it has to get back to 0. If x is negative and a is positive, then b must be positive. And if x is negative and a is negative, then b must be negative. Okay, so without thinking about the quantity, although that would come into play as well, just thinking about positives, negatives here, these are kind of the 4 possible situations. And I'm just telling you guys, anytime on the GMAT you can constrain yourself, better. Constraints of freedom. You don't have to think about as much. Okay, and so whatever the quantities are, at least I know it's going to be one of these 4 possibilities. And so I kind of want to know, all right, well, what's the deal with a and b? What's going on with a and b? Because if they're both positive or both negative, then x is negative. If they're of different signs, it's x is positive. Okay, that's really the secret to this problem. So statement 1 tells me a plus b is positive. Well, we saw that earlier. What that meant that, you know, I have a and b. Either they're both positive like this. I'm sorry, like these two, or they are positive and negative, but the one that is less negative is less negative. Okay, and I can do the same setup here with a flip where b is here and a is either the small positive or small negative. Okay, I don't know which, so that's not sufficient. Statement 2 tells me a is greater than b. Okay, but I already have, so it can't be this bottom line. Okay, I've already considered that though in statement 1. That's this. Both of those a is greater than b. Are they both positive? Maybe. Are they both negative? No, but it could be one positive, one negative. Okay, so that's insufficient. And then when I bring the 2 together, I really am in the same situation. When I bring the 2 together, I have a b that is possibly negative and an a that is positive, or a b that is positive and an a that is positive. And so I either have 2 positives, which is here, where x is negative, or I have a is positive and b is negative, which is here, where x is positive. So I can't answer this question. The answer to this one is also E, no sufficiency. Okay. Now again, there are other ways to do this question. When I actually did this one, I think on the test that I live streamed, and I did it picking numbers. I tested cases. Okay, and it worked. It was tiresome, but it worked. There's also some algebra you can do. There are other ways to do this stuff. I just want you to build a toolkit. Okay, for the whole test, you always want to find as many ways to crack through this stuff as you can. And I find the not having to deal with actual numbers and just seeing this as placement is very helpful. Okay. Jay says, could I go again through C and E? Well, so C, when I bring the 2 statements together, Jay, I'm in this possible, I'm in these 2 possible number lines when I bring the 2 statements together. Either A and B are both positive. Haywire here. Okay. Either A and B are both positive, in which case x is negative, or there are different signs. A is positive and B is negative, in which case x is positive. So since I don't know which I'm in, I can't say if x is positive or negative. I must say E, no sufficiency. Okay. This down here is where I'm trying to test C, and there's just not enough information. Okay. So let's find I'm going to spoil it for you. We're going to find a question where the answer is not E. I've forgotten those 2 had the same answer. That one's pretty good. That one's pretty good. Let's do this one's fun. Yeah, take 2 minutes to try this question. Okay, friends. So this one is fun. This one is a good candidate for, I think, seeing how to use number lines to your advantage here. We're asked, is x, y greater than 0? Well, that means we're wondering, are x and y both positive or both negative? I'm sorry, or both negative. Those are the outcomes where x times y is greater than 0. If they are on opposite sides of the number line, then the product will be less than 0. Okay, so let's go through the number line possibilities in the statement. Statement 1 tells me x minus y is greater than -2. It might help to rearrange that, perhaps. You don't have to if you're very good at this concept of distance and inequalities. But if I add 2 and I add y and I subtract x, I get 2 is greater than y minus x. Okay, so what that means, y minus x is the distance between y and x. And I'm told it's less than 2. I feel like I've done something wrong. I'm being sloppy. X minus y is 2 is greater than the distance between y and x. 2 is the maximum. Yes. So 2 is the absolute maximum of the distance between y and x. So what that means is that I have x and y on the number line, and if the distance between x and y must be, where 2 is the absolute threshold. And I say distance. It's really not distance because I don't know if y minus x is positive or not. That's kind of the trick here. That's what this negative sign means. But I know that the absolute furthest they can be in this instance is 2. Okay, that'd be where x minus y equals -2. If x minus y equals -2, we saw this earlier in our warm-ups here, then that means x is 2 less than y. And that's his absolute maximum for x to be as far away from y in this direction. Otherwise, x is going to be this way, where the distance between them closes in, and then it's 0. And then in all these other instances, x is bigger than y. When x is over here, x is greater than y, and x minus y is positive. Okay, but are they both positive or negative? I have no idea. Nothing about this tells me where x and y are relative to 0. Okay, I don't know if 0 is here or here or here. No idea. No idea about 0. So I can't tell you about the signs of x and y here. Okay. Statement 2 tells me x minus 2y is less than -6. Okay. So since x minus 2y is negative, because it's less than -6, I know x is less than 2y. I know x falls to the left of 2y. Okay. And I know that since the distance, since x minus 2y is less than -6, the absolute maximum distance between these two is 6. And x has got to be left of that, because we're told x minus 2y is less than -6. Okay. But again, where is 0? I don't know. I don't know where 0 is. I don't even know where y is. I don't know if y is here or if y is here. And that will be an important distinction here when we bring things together. Okay. I don't know where 0 is. I don't know where y is. Can't tell. But now, let's bring stuff together here. Now, so I've gotten rid of A and D and B. Now I'm testing C or E. And since I told you it's not E, you're going to find out that the answer is C. Let's think about Y. Hey gang, this is Reed. I'm recording this a few days after the free GMAT prep hour because it was at this point in the lesson that things went a little awry. I had prepped this question with the understanding the answer was C, and then in the middle of teaching it, I had this like flash of panic where I thought, oh no, the answer is E, I've made a terrible mistake. And then the explanation got muddy and I started to teach it as if the answer was E, and then I realized afterwards that no, wait, the answer is C, and I had to go back and it just got kind of chaotic. So I'm just going to lay out the explanation here clearly let you know why the answer is in fact C. So the question is x times y positive? That is asking if they are both on the same side of 0. Okay. Statement 1 I laid out correctly in the video so far. It does tell me that, hey, x is to the left of y by 2 at most, or this way. It moves in that direction. And that's not sufficient because I don't know where 0 is. Who knows? Statement 2 does tell me, hey, I have 2y here, and I have x here, and x is 6 to the left of that, or more. In fact, it's actually more than 6 to the left of that, since it can't be exactly 6. So that's not sufficient, though, because again, I don't know where 0 is. Is 0 here or here? Nobody knows. And I was bringing it together where things got particularly fun. So when we bring the two rules together, okay, we're going to have to follow both rules at once. So we know that x is at least 6 away from 2y, or in this direction. Okay. Well, let's imagine a case where y is positive. I'm sorry, negative. Excuse me, negative. That's going to cause some problems here, because if y is negative, then by statement 1, we know that x is 2 to the left of y, or that direction. Okay. And the problem here is that this spacing doesn't work. X is in 2 places at the number line at once. That's not allowed. So that tells me that y cannot be negative. So I know that y has to be positive. Okay. So let's build this number line. We have 0. We know that y is here, and we know that 2y is somewhere over here. And now we have to follow all of the rules. Statement 2 tells me that x is at least 6 to the left of 2y. And statement 1 tells me that x is 2 to the left of y, or to the right of that point. So I have this like orange band of possible x's. And the thing about all those x's is that they're all positive. And y was positive, so x times y would be positive in this case. The moment of panic was that I wasn't sure if 0, I had this flash of like, oh no, what if 0 falls right here in between x and y? And I realized eventually that that cannot be the case. If you try to do that, you're going to find the spacing just doesn't work. If I make x here, which is, put y really, really close to 0, x is, 2 away. It's almost, let's say, -2. Let's put x at -2. That's like if y is almost 0, x is almost -2, or to the right of that point. And that would put y at almost 0, so 2y would be almost 0 as well, basically, because 2 times a little bit more than 0 is still just a little bit more than 0. The problem is that then, if I follow statement 2's rules, x has to be 6 away from 2y, excuse me. And 6 away from almost 0 puts x at -6, or to the left. And again, I find myself in a situation where x is like less than -6, or greater than -2, or greater than -2 and greater than -2. It's in 2 places at once, and that's just not allowed. So I realized, no, hold up. It has to be the situation where they're both positive. It's nice and clean. And so the answer is C. Let's do that one. I've done on a test before. We could do it again. This one's a good one. Do this one, because I know the answer is not here for this one. Take 2 minutes. Okay, friends, I might go back to the one we just did because I might have been correct the first time and messed up the second time. I'm looking into it. Let's take a look at this one though, because I do know how this one works. So we're asked, is m plus z greater than 0? Okay, statement 1 tells me m is greater than 3z. On the number line, that means that I have m and I have 3z. Okay, is m plus z greater than 0? I don't know. Where is z? Are they both negative? Are they both positive? It's very possible to imagine that, they're both negative and 0 is over here. Okay, and z is wherever it is, who cares? Or it's possible that they're both positive, and 0 is here, and z is here, and they add positive. So either, it's very possible to imagine them both being negative or both being positive. Statement 2 is going to have a very similar situation. I'm told that 4z is greater than m, so I have 4z is greater than m, but again, where is 0? It's possible that it's over here. It's possible that it's over here. Who knows? So that's not sufficient. But when we bring things together, this is where things get kind of fun. I'm told that m is greater than 3z. So I know that m is here, and I also know that m is less than 4z. So I know that 4z is somewhere here. Okay, well, in this case, where is 0? There's only one option. 0 has to be over here. If 0 was over here, 4z and 3z doesn't make sense. 4z is further away from 0 than 3z is, no matter which way, no matter if z is positive or negative. And so if 4z is further away from 0, 0 can't be there. 0 must be here, which means that z must be positive, which means that z plus m must be positive. Okay. And so yes, there are other ways to do this question. You can test cases, you can test numbers. It does theoretically work, but I find the visualization of the number line much easier, despite the fact that that last question I'm still kind of wrestling with. It's not always the best way, for sure, but I have found that certain questions have really been made much easier when I actually visualize them. If you all watch the video, I'm not going to do the problem again because you've already seen me do the problem, or you can see me do the problem. If you look at the video Twitch the GMAT, an expert takes the quant section, this question here shows up. I think it's the second to last question I do on that test. And this was my exact weakness, and I was running out of time, and it was like, can I do this? And I was like, well, I've practiced this number line stuff. Let me see if it tells me anything. Yeah, I will do it. Why not? You got me here, and I'm talking about it. So we're asked if the distance between x and y is greater than the distance of 0 to x minus the distance of 0 to y. Okay. So let's think about that for a second. Let's not go to the statements too fast. The distance between x and y, is it greater than the distance of 0 to x and the distance of 0 to y? Well, let's think about instances where it's not greater than. When is it going to be equal to? And that's going to be situations where x and y are set up like this, because in this case, this is the distance between x and y. And here's the distance from 0 to x, and here's the distance of 0 to y. And I can just see visually how the subtraction would result in an equal sign, not a greater than sign. Same thing happens if x and y are negative. If I have 0 here and x here and y here, then the distance between x and y, which is this, equals the distance from 0 to x minus the distance from 0 to y. Okay. So the question is, when is it greater than? I see where it's equal, when they're both on the same side and x is further away from 0. When is this distance between x and y greater than absolute value of x and absolute value of y? And there's a few situations. Namely, if y is further away from 0, so that would do it. If I knew y was, say, over here, that would absolutely make this, because this would be positive, and then this would be negative. So if y is over here, game over. Okay. the other option is that if they are on different sides of the number line, the distance between x and y is going to be much bigger than the distance from 0 to x minus the distance of 0 to y. Okay, and think about subtracting this length and this length. Of course, this is going to be bigger. And so this hellish question is really asking, are x and y on either is y further away from 0 than x, or are x and y on opposite sides of the number line? That's really what it's asking. Is absolute value, is y further away from 0 than x is, or is x, y negative? Statement 1 tells me y is less than x, but I don't know if that's like here or if it's like here. So I can't say that's sufficient. But statement 2 just tells me, yeah, they're on opposite sides of the number line. And again, I could test cases with it, but I just, really bums me out. The visualization of the number lines as distances just makes this so much easier for me. So I'm going to pause the recording here. That'll be it for tonight. I'm going to pause the recording and check my work on the one question I still have a question about. And if I catch myself that I have made a mistake, I'll come back and correct it so that our lovely video editors can make sure that the correction is added to the end. Sorry, guys. Everyone at home, thank you for joining me. Everyone watching the recording, thank you for watching. Practice this, especially if you hate, like I do, absolute values mixed with inequalities. Thinking about where the numbers fall in the number line has been a very helpful thing, despite that one question. It's really helped me get better at that and not have to deal with all the possible numbers, just actually see the things as places and positions on a number line. All right, we'll be doing this again shortly. I look forward to seeing you then. I'll stick around to answer any questions from the audience who is here. Otherwise, best of luck in your studies.